I'm going to give an interactive session, so if you want to grab your laptop or tablet, and we're going to try and make sure everyone can code along in this. So the title's a bit of a mouthful, so I'm not going to read it out, but if you've done no Python coding at all, then this is probably a really good introductory session. And I'll try and explain why some of these things, despite the fact they seem quite abstract, why they're actually really useful and how you might use them if you're writing a script in the future at some point. So it's kind of essential really that you grab these slides. So this is an exact copy of the slides that I'm using, and if you can't see the screen, then you can just listen to me and look at the slides as I work my way through them. And there are really useful links in there, so we're going to be using links from there and doing a bit of coding using Google Collab. So absolutely essential to just grab those. Someone confirm that it's actually downloading something. It's always good news. Everyone got a copy of that? Error, not ideal. Try again.
Is it J at the end?
I think it is a J, yeah. I think it would be a very strange I with that long tail on it. Okay, shall I move on? Haven't got them open? So my name's James Smith. I'm the CTO of Projecting Success. I have a PhD in applied mathematics, and I concentrated on the Panelet equations, if you're interested in applied mathematics. And I spent a couple of years teaching at the University of Kent before I swapped into industry in 2017. So a little bit about my interests, in case you don't know. Interested in mathematics, obviously, and modelling. Really quite passionate about machine learning, do a lot of reading about it in my own time, and fascinated with modelling and how I can integrate that with other things I like maths. And then really enjoy kind of computers and technology and coding and all the things that kind of go hand in hand with data science, really. So just a little bit of history about Python. So it was created in 1991. So it's not, in terms of programming languages, it's actually very, very young. It was inspired by the language C, which some of you may have heard of, and Modular 3 and ABC as well. And it gets its name, so much like one of the challenges taking their name from the Monty Python's Flying Circus, Python was actually inspired by that as well. And it's actually controlled, so all the Python releases we get, we're not actually going to be downloading it today, but if you were to download Python, then all of that's controlled by the Python Software Foundation. So they'll release all of the updates and control all of the open source software. So I think Python really emphasizes on code readability. So you might struggle to read some of the code today, and that's perfectly reasonable because we will look at some more complicated things. But because of the indentation you get with Python, it really kind of separates itself and lends itself to beginners because you can read the code so nicely. And another reason it's really kind of taken off is because of its flexibility. So you can use it for data analytics, you can use it to build machine learning models, you can use it to plot graphs, you can use it to build websites, you can use it to build APIs, you can make web scraping bots with it, you can use it as an ETL tool, an extract, transform and load tool. Really, you can kind of do anything with it, to be honest. So that flexibility really is attractive to people, and that's why it's getting so much traction. And in my sort of experience, the closer you are to kind of an engineering background or that sort of engineering environment, or maybe even industry environment, the more likely you are to want to use Python as opposed to other coding languages which are very, very good. I'm not going to slate them like R and other types of languages. So Google Collab, who's heard of Collab? No one? So, who's heard of Jupyter Notebooks? A few hands. So, Jupyter Notebooks is it's an IDE, so an integrated development environment. So rather than just running Python in your command prompt and not being able to save your scripts and having to run a line of code every time, not being able to edit anything, you have a piece of software where you can, it does all your code highlighting for you, so it helps you with recognizing variables and different objects in your code. It does automatic indentation, it auto-completes sentences for you. You can save your scripts, and you can also, it has a nice output window for you, so you can see what code you're outputting. So there are lots of different IDEs, and people use different ones, and this is Jupyter Notebooks, comes as part of an Anaconda distribution, but then Google Colab is a free Jupyter Notebook, but it all runs within Google's servers. So that's why we're not installing anything. So when I usually code, I code locally on my machine, I have Python installed, but to avoid any installing errors, we're going to do it all in the cloud. So we're connecting to a real Python environment. We're just doing it all through the internet. And I really recommend Google Colab. If you're just starting off, you don't have to worry about installing anything, messing it up, not being able to connect to the right kernel. It's all free as well. So some of the machines are quite slow, which is the drawback, but you can't really complain when you're not paying anything. You can also, so there are lots of sort of templates and tutorials for you to look at, and we'll do some of that. So it's probably worth people just either taking a copy of that link or just opening that browser, and you get presented with this nice orange window. The really nice thing about Collab is because it's Google, and I shouldn't say Google so much when we're standing in the Microsoft reactor, I might get sniped or something, but you can connect to your Google Drive. So just like we're using Google Drive here to host all the data, so you can pull in your data from your Google Drive, so you don't have to always load your scripts and upload data. You can work completely within your cloud environment, which is also really nice. We're going to be pulling in data from GitHub today. So hopefully you've been presented with this window. It's a bit unclear on my screen, but hopefully on yours you should see examples. So there are a few Google Colab examples there for you to look at. Recent files, so files you've loaded in the last few days. Like I said, you can connect to Google Drive and load in data and files from there. You can connect to GitHub through the GitHub tab, which is what we're doing in a minute. And the last one is upload, I think, does it say? Where you can obviously upload scripts to it as well, to your Google Drive, etc. So this is the charting in Collab. So if you, I think it's it's the first tab, it's one of the templates. If you just click that, and you'll show it loads a really nice piece of code, and then and walks through some of the charting options within Matplotlib, I think. But don't worry too much about that now. It's just showing you how you kind of load different scripts. Does anybody know what GitHub is? Yeah, you've heard of GitHub. You know what it's kind of for. So GitHub is a really useful tool for collaborating with people when writing code. So to make sure that people don't overwrite different bits of code or they don't break it, you can do a bit of coding locally on your machine, and then you say, yep, this is all working, and you can push it to the server and then save that, and then somebody else who wants to work on it can pull that bit of code down, make an amendment, and then they can upload it, and you have different kind of channels. So you make a different branch off, and you can push it into a different branch, and then someone can come in and verify and say, yes, they haven't broken my code, they've made a valid improvement, and then you can merge it with the main branch, what we call the master branch. So it's a foolproof way of people kind of collaborating, and it handles all your version controlling, so you can roll back the code. It's really useful if you're working with lots of people. GitHub is open to the public, so anything you have, any files you have on there will be accessible to the public, so don't go putting things on there that any commercially sensitive information or anything like that. If you do want to do that, there's a version called GitLab, which we use within the company a little bit. So if you take a copy of this link, you should be able to right-click it and just click copy link. That's a copy, or you can open it and have a look. And it's just a piece of code that I've written for this session that you're going to load into Collab. Okay, so it's just something that I've saved on my on my GitHub account, sorry. That's hopefully should complement all of my slides nicely. So if you just take that URL, go back to the Google Collab page, click on the tab that says GitHub, and then just paste it in there, and then click on the magnifying glass thing, and then it should load the code. And I'm going to do the same thing as well. So you can see in this browser you've got various bits of code. So under Python data types, you can see I've already got code you can write in there. And to the left of it, if you hover over those two square brackets, you'll see that there's like a play button pops up. And if you press those things, it will run those bits of code. So before you go through and press them all at once, we're going to walk through and show you what these things actually mean. So I'm going to stick to the slides, and you guys kind of, I think it's probably best if you kind of split your screen half on the slides, or feel free to look at mine and then run the code as we go through. So we're going to start off. Why has that happened? Looks like my slides are stuck. So where did we get to? So we're going to start off talking about some Python data types, different types of data you get. Then we're going to talk about variables, naming conventions, and the print function. Then we'll move on to string operations. And then finally we'll talk quickly about some procedures and functions. So within Python data types, we will cover everything from number operations all the way down to dictionaries. So who's familiar with these three different types of data? So integers, people familiar with integers? So these are our whole numbers, okay? Sorry, Ben, what was that?
The notebook in your Collab.
It's not called Intro to ML. Sorted? And then you have floating point numbers, so these are your numbers with decimal points in them. Okay, and then finally we have complex numbers as well. So don't worry if you don't know what complex numbers are. This is 4 plus 5j or I. It's j if you're an engineer, but I if you're a mathematician. And this I is equal to the square root of -1, but we won't get into too much detail there. But those are the three different types of numbers, and you should have. Because when I change screens, I can't control this, which is quite annoying. You should have examples of an integer, a complex number, and a floating point number. So if you run those, then the output will show you, and I've also got the type function there so you can see what type of. Is that working for everyone? So if you can see under Python data types, you've got the integer 5. So when you run it, it will come up with a warning and say this has not been authorized by Google. Well, that's because it's my script. I can assure you it's perfectly safe. You just click run, and it will run that piece of code and show you. It will just have the output 5. Yeah. And then below all of those, I'm using the type function. So it's just telling you. So Python's automatically assigning a type to those number types or data types, and it's just telling you what it is, whether it's an integer, a complex number, or what have you. Okay, so in Python, we've got lots of number operations, so addition. So it's just that you'd expect, you can do 2 plus 2, okay, and subtraction as you'd expect, you can do 5 minus 1, and in your number operations bit, you've also got code for this, so just keep running it as I keep going. You've also got multiplication, so we use the star operator, so just like we would in Excel. And we've also got the division operator as well, so it works exactly as you would expect. And an integer divided by, in this case, 10 divided by 2 just gives you the integer that you would expect. Is everyone, I see a few people panicking a bit. Is this working for everybody?
I've got it up where you put up the whole screen and you've done fun stuff. But how do you, when in Google Collab,
Yeah.
it comes up with all the notebooks. You can go and open a particular notebook, but how do you open a page that's got everything on it? How do you open this page?
Ben, can you help? Sorry, what?
How do you get to this page?
Somebody's saying scroll to the bottom, Rishi. Is that helping?
I got it, I just don't know how I did it.
Oh, okay. Right. Everybody with me, what I'm doing? Yeah? So, Boolean. So, in Python, a Boolean expression is an expression that can take two values, either true or false. Okay? So, good example is this, is if we set x equal to 15, this is a variable and we'll come to this later, and we said is 15 an integer, it would return, Python will return true. So you can run that and verify that. We've also got this inverter keyword, so we can put not in front of true and that's equal to false. Equally, we can put not in front of false and that's equal to true. Ken?
Can you do not true?
Try it. Try it. Type not true, see what happens. You can, you're welcome to modify my code, see what happens. Right. So there might be, you might have hidden cells in your script, you just need to click it and it opens them up for you. Right, strings, have I skipped ahead or is that where we are next? Did we skip? No, I'm having a bit of trouble. Strings is next, excellent. Having a bit of trouble making my slides move along. But, okay, so a string in Python is just a sequence of characters. Okay, so you probably hear data people talking about strings all the time, but just think, if we talk about strings, just think of a sequence of characters where the symbols are just letters in the alphabet, okay? Computers don't deal with letters or characters very well. They obviously, everything is all coded in binary. So we have these encoders. So to encode the binary, we use various different encoders. So don't worry too much. As long as you're seeing your characters on screen, you're fine. But what actually is happening is the binary is being converted using one of these encoders. It's really easy to create strings. So we've got 3 examples, I think, in our Collab. So you just encase them in quotation marks. So you can either use double quotes, single quotes, and if you've got an apostrophe in there, like it's a sunny day, then you just need to use double quotes on the outside. So lists. So I guess people can see why strings might be useful for us. And lists are incredibly useful, and I'll try and justify why they might be. So List in Python is just a data type that involves compounding other data types. So to create a list, we just list elements inside of square brackets, and then we separate them using commas. And they can contain any number of items. They can even have nothing in them. You can have an empty list, and they can contain integers, floats, strings, whatever you want. So we've just got some examples. So we've got an empty set, like an empty list, sorry. We've got a list containing only integers, and we've got a list containing strings, a float, and integers. And so you might be thinking, when on earth would I ever use this kind of thing? And actually, when you really get stuck into data analytics or data cleaning, then you use these kind of things all the time. So you have a piece of code that you want to execute over and over and over again. So for example, if you had a lot of unstructured data, so let's say you had a lot of CV files, so you had thousands and thousands of them, you work in HR or something, and you wanted to extract the names and the addresses from these CSV files, and it would take you weeks to do it by hand, then you could tell Python to look in a particular folder where all these CV files are, and it would create a list of their paths to those files. So it would be able to, you could say, tell me, create a list with all these CV files that end with extension .pdf or something. So you could have a list that's got 1,000 different file extensions in it and path URLs, and then you could create a piece of code that opens that file up, reads the data in, extracts, say, the name and the address, and then you can loop through this list and just apply that function over and over again. So you'd start on the first one, you'd open that file up, and you'd extract that information, and then because you're iterating, you'd move on to the next thing, open up the next file, extract that information, and then and do whatever you need to do with it. So it seems a bit abstract, but we're just chucking random things in here, but this is how you can really optimize some of your maybe data cleansing using these kind of data types. So another data type, so similar to a list, is a tuple. So the difference between the two is that this is immutable, so we can't change the elements once we've created it. It means that we separate them with parentheses, so just normal brackets as opposed to square brackets. And generally, they're a little bit faster than lists because there's no chance that, because they're immutable, there's no chance they can be edited. So again, you've just got a quick example there with an integer and some strings. So sets, again, very similar. This time, we encase them with curly brackets. And they're also immutable as well. So very similar to tuples and lists. Dictionaries, so slightly different. So this is an unordered collection of items, but each value in it has what we call a key value pair. So if we wanted to access apple, it's got this key value pair of 1, bananas associated to 2, and oranges 3. So you could use this if you wanted to replace bits of information within, say, a CSV file with items in your dictionary. We've got some examples there which you can run on your own script, of course. Does that make sense to everyone so far? Code helping? Good. So variables and naming conventions and then the print function is what we're going to talk about now. So we've already saw one variable when we assigned x to be 15. And so we use variables in Python as for containers for storing data values. So in some programming languages, you have to define when you're going to store data as a variable. In Python, as soon as you do it, that variable is created for you. And you don't even have to tell it what type the variable is, it automatically assigns it. So when we typed x equals 5, it's automatically assigns x to be an integer. And then variables must start with a letter or an underscore, and they cannot start with a number. And they, excuse me, we can only contain alphanumeric characters and underscores. So some examples: capital X equals this integer 7, name is equal to the string Bob, and underscore weather is also the string it is sunny today. So naming conventions, and we won't get too bogged down in this because probably we could talk about this for a long time, but it wouldn't be that useful. But there are lots of different naming conventions and rules to follow when you start your kind of Python adventures, and a really good place to start. So you shouldn't write more than a certain number of characters on a line because it's considered bad practice. But a lot of these kind of rules can be found in this documentation within your, and we conform to, a lot of people conform to Python's PEP8 formation, which is the documentation I've given you. So when you're naming some of your variables, you don't want them to be too general, but you also don't want them to be too wordy. You want to find the right balance. So some examples of bad variable names, things like move ints, swap nums, and then some good versions are things like user info, move integers. And it's really tempting, and I was guilty of this when I started, but really try not to name things without kind of thinking about it. So don't start calling things X, Y, or Z when you're writing functions, which we'll talk about later, because you'll just end up confusing yourself eventually. So the print function. So you should have some examples of using the print function. I think, do we print hello world? So this is one of the most important functions probably in Python. So in Collab, whenever you run a piece of code, it will print out the result for you. But if you were using a different IDE, so I was coding on my laptop, I'd use a different IDE like Spider. If I ran a piece of code, I would have no printout at all. It would just run the code. It would only print something to the console if I said print. Okay, so you can use it as a method to check that your code's run the right way, you're getting the right output. But in things like Collab and Jupyter Notebooks, which you're using, it's much more transparent about what's actually the output from that cell. So string operations, very, very important when it comes to cleaning data. So Python has lots of methods for performing tasks to string objects, and we'll look at some of the more common ones here. And there are a lot. So we can do things like capitalization easily, find the length, split strings, and we'll just look at some of the inbuilt functions to start off with. So let's assume that the word string is some string that we've created, like it's really fabulous weather today or something. So if you use dot lower, then it would just lowercase everything, and dot upper will of course uppercase everything, and with capitalize, so it will just capitalize the first letter. It is with a Z, I'm afraid. Strip will strip the leading and trailing white space. So you might have a string that's actually got spaces in front of it or behind it, which can cause a lot of issues, of course, when you're trying to match it with something. I'm sure you've come across that kind of issue with Excel. It will just strip anything off of that string. And then there's a split function as well. So you could split a string. So say my name, James Smith, if I was to split on that, it would turn that into a list and split it on the separator that I specified. And if you specify nothing, it will use white space. So my name would become, inside square brackets, because it turns it into a list, would be James, Smith. And you should have some examples of that as well. So string slicing. So this is all about indexing your strings. So if we had the variable string John, so just the name John, we wanted to slice it, then if we use square brackets, and this is starting at the index 0, so capital J, and then we're finishing at 2, but it doesn't include that index, so we're just going to get capital J lowercase o. Okay? But equally, we don't need that 0, so if you don't include it, then it assumes you're starting from 0 anywhere. So colon 2 is actually the same as 0 colon 2. Does that make sense? Yeah? And you'd find, this might seem quite abstract, but if you're cleaning strings, so if you were iterating through a CSV file and you always had characters on there that you didn't want, so you always had, I don't know, say a hyphen on the end of your strings and you wanted to remove it, then you could use techniques like this to iterate through each one. So you'd convert them all into a list, apply a function to them individually and clean them all. And then obviously you can start from, you don't have to start from 0, we can start from 1, and then we get everything to the end. Because we've got colon and then nothing, it assumes that we want everything right to the end. So in this case we'd get lowercase o, h and n. You also get reverse indexes as well. So the index 0 is equivalent to the index -4, and the index 3 is equivalent to the index -1. So that if you take a string and index -1, you'll always end up with the last thing in this string. And equally, if you took -2, you'd end up with the penultimate character in that string. So it's like a little fun exercise. So you can code, this is not fixed. You can edit this code. So can you print out all but the last 2 letters of the string John? Whilst you do that, I'll try and get my page to scroll down because it doesn't seem to be working so well. So I've already, in the exercise section, I've already left you a nice blank cell, so you can just tap on that and type in there. So you should, below exercise, you should have a blank cell all ready for you to type your solutions. So you know what you want it to print out, all but the last 2 letters. So you just want to print out, excuse me, the capital J and lowercase o. Does anyone know how to do it? Yeah, someone want to shout out, be brave, shout something out? No? So you could do this using, obviously, name, so that's your string, and then colon, then -2. Yeah? And if you didn't type that in, feel free to type that in and run it, and you'll see we should have the right output. So just before I finish, do you think, so despite the fact these things might seem quite abstract, do you think it's clear why these might become useful for you if you started to clean data? And it's all about, coding is all about us being as efficient as possible. So if you write a function to do something and you want to apply it in lots of different areas, you can use iteration to allow you to not duplicate your code all over the place, basically. So procedures and functions, and then we're going to just look briefly at the Fibonacci sequence. So a procedure is a piece of code that needs to be run. If you need a piece of code to be run several times, then you'd write it into a procedure. So like I said, we could loop through or iterate through a particular list and use that piece of code again and again and again. This is an example of a procedure. So we define it by using the def. So then we call a procedure by the characters that we type here. So this is called output. Then we have number, which is a dummy variable. Okay, so whichever number we put in as the dummy variable, that would become number in this instance. So that we print number, then it will print this string, squared equals, and then it will calculate number times number. Okay, so with this will compute 8 times 8 and print 8, and then it will print the squared equal to 8 times 8, which is 64. Yeah? Does that make sense? So that's a very, very simple procedure. And then I've said try a few more. So maybe try chucking your favorite integer in there and watch Python square it for you. You can have optional parameters as well. So this is where it gets a little bit more tricky. So again, we define this, our function as output, and then we've got 3 parameters in here, but 2 of them already have equal signs in them, so they're optional. So we could just output C, or we could output, so if we set the score to be 87, then it won't be 50 anymore. We've sort of overridden it in a way. And again, if we specify we want 3 parameters, then the feedback is no longer well done. And you can, if you run these, then you can see the different outputs for all of them. Does that make sense? So in the first example, we had 1 parameter, we just had to put 1 integer in it, but you can specify the number of essential parameters and optional parameters as well. So a function is a procedure, but when we return something. So here we've got another function, or we've got a procedure, but we're actually making a return statement. So despite the fact you're having an output, you're not actually, if you applied this function without a return statement, then there would actually be no output out of it. So it's difficult to explain, but without that, you're actually just making a computation for no reason. It's not actually going anywhere or being used. So again, if we define this function, now our function is called calculate. Number is our dummy variable. Okay, so new number is going to be our dummy variable divided by 100, and then it returns new number. So if this was a function that we were using to clean maybe a big long string of numbers for whatever reason, then the return function would be our output from that, and that's what we would actually want to be using if we were doing some kind of data cleaning. And you can see what happens if we set our variable here to be 6,400. So finally, the Fibonacci sequence. Who's heard of that? The Fibonacci sequence. So this is the sequence of numbers 0, 1, 1, 2, 3, 5, etc., etc. Okay, and we calculate the next number by just adding the last 2 up. Okay, so we index it with 0 and 1. So indexing with 0 and 1. And the 1 comes from adding 0 and 1 together to get 1. The 2 comes from adding the 2 ones. Okay, the 3 comes from adding the 2 and the 1. The 5 comes from adding the 3 and the 2, etc., etc. So this is the formula. xn is the last value, xn to the minus 1, plus the value before that, xn to the minus 2. So can you create a function in Python, and I don't expect people to nail this immediately, that's able to find the nth number in the Fibonacci sequence? So we need to create a function, we need to define a function that allows us to enter a number into it. You need to initiate it. Granted, this is going to be quite hard with those 2 initiation values, so 0 and 1, so that it will go and compute. Ideally, we want the 10th number and the 35th number as well. And even at these points, these numbers are going to be massive. I think the 35th number there is well into the millions at that point. So this is when using something like Google Collab is really useful, because if you're doing this locally, this is a significant amount of computation, then your laptop might be getting quite warm at this point. So at least Google's computers are getting warm somewhere. Anyone got any idea about how to do this?
First you have to say 0 and 1.
Yes, you definitely need to initialize it. So if we defined our function to be Fibonacci, and we had the dummy variable n. No, I'm so sorry. So if we have an if statement now, so if n is equal to, and this double equals means we're not assigning it, we're just checking. If n is equal to 1 or n is equal to 2, then we return 1. And then this else means, so if that's not satisfied, then we compute this action. And this is what I mean about Python having this nice indentation. So you always indent after a function, like we've seen, and you always indent after a statement. So this is an if statement, and this is an else statement. So we always have a colon on the end of these things as well. So if that is not true, if n is not equal to 1 or 2, then we would return Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So if you were to put the Fibonacci of 3 in here, so if you ran Fibonacci 3, it's going to, n, our dummy variable, is going to be 3. It's going to say, is n equal to 1 or 2? It is not, because it's equal to 3. So it's going to skip to else, and then it's going to calculate, so remember n is 3. It's going to calculate Fibonacci of 2, okay, and Fibonacci of 1. And it's going to do that by looking back in here and saying, so now n has reduced by 1 and 2. So it's going to say, is n equal to 1, which it is, and in the other case, n was equal to 2. See some blank faces.
What if you take a bigger number, say 20?
So I'm not going to work through that because that would take us a little while. But if you took 20, we could do the first. So we write Fibonacci of 20, okay? So now n is equal to 20. It says, is n equal to 1 or 2? It's not. So we don't return 1. We're in the else. So it will complete Fibonacci of 19 and the Fibonacci of 18. Okay, so Fibonacci of 19, it will now compute. It says, is n equal to 1 or 2? It's not, it's 19. Okay, so it will go and compute 19 here. So it will be the Fibonacci of 18 and the Fibonacci of 17. And it will go back until it will keep going until it gets down to n is 1 or 2. And then it will give you return 1. Okay, but we also didn't account for the other scenario. Did you say 20? Fibonacci of 20. So that was only this case. It's also going to calculate the Fibonacci of 18. So it's going to do that. It's going to say n is 18. Is n equal to 1 or 2? It's not. So it's going to calculate Fibonacci of 17 and the Fibonacci of 16. So you can see it's a recursive thing. It's just going and going and going and going until these dummy variables reduce enough that it's satisfied with returning 1.
What is the use case for this Fibonacci?
Fibonacci sequence is used, it springs up in nature, all over the place. It's very closely related to the golden ratio. So this is a ratio between two different lengths. I think it's a plus b divided by b is proportional to a over b. So it crops up all over the place. You can see it in nature, we can see it in geometry. It's really, it's all over the place, to be honest.
Not for the running total or anything like that?
No. Well, I don't know. It's sure it's got applications absolutely everywhere. It's just an interesting, not only is it a very kind of natural and phenomenon, but it's also very interesting to study mathematically as well. Yes? Sorry? Sorry, you're going to have to... Yes, yeah, very similar to fractals, yeah. So, does that make sense? And you can take, run some of these Fibonacci's, run Fibonacci of 35. Has some people got an answer for that? You do?
It's a question. I want to ask you a question.
Okay, go ahead.
I see a lot of similarities with Python and what's the difference?
I would say there is a lot of similarity. To be honest, you could do all of this stuff in R as well. R is primarily used in a sort of research background because it's really good at calculating statistics, to be honest. Python can do most things that R can, but it just has a lot more functionality built into it. The learning curve for R is a bit steeper at the beginning. But once you've made that kind of investment, then you can write very complex programs in just a few lines, which is very appealing. Whereas Python is probably better for people that don't know programming languages because of you might take you a few more lines of code to write the same program, but it will be quicker and easier to do because it won't be as complicated. As soon as you condense it, it gets more complicated. So does someone have a solution for Fibonacci of 35?
One more step missing. Where do I put 35?
So you need to, just like we did when we were making those outputs before, you need to have Fibonacci, just write the word Fibonacci, open bracket, 35 and then close bracket. And you should have your output. And I think as soon as somebody gives me a solution for that,
9 million.
yeah, that sounds familiar. Is that 9 million something? Yeah. So it's yeah, you get in the Fibonacci sequence you get extremely big numbers extremely quickly. So I think I am out of time, but there's some extra functions for you to play with, and we can talk through afterwards. But I don't want to encroach onto someone else's masterclass. So thank you very much, and if you have any questions, I'm here all day, so please come and find me.